In this video, we'll discuss different characteristics that define the shape of distributions and some overall patterns that you may often see. First, I think it's good practice to always visually examine the distribution of your data in some way before you proceed too far with your analysis and interpretation. Is your understanding of the data correct? Is the shape of the distribution what you expected? Does it look like what you think it should? Are there any weird spikes or patterns in the data? If something does seem odd or unexpected, what are the possible explanations? Maybe there were subtleties or things you didn't expect. Maybe there's a coding problem or a poorly worded question or a variable that doesn't mean what you think it does. I have a separate video that talks about some examples of those. Regardless, there may be implications for your analysis and your interpretation of the results. Ultimately, the shape of the distribution will give you key information that you need to know in order to analyze the data correctly. It will also influence how you interpret your data and whether that interpretation is accurate. So let's take a look at three fundamental features of distribution shapes that you need to pay attention to. To do that, let's use this distribution as an example. Here's a histogram of birth weights for babies born in the United States in 2018. It's fairly typical, rather normal looking. We'll come back to that later. It highlights three general fundamental characteristics of distributions. First, central tendency. What's a typical middle-ish sort of score? In this case, notice that there is a clear middle of the distribution. Now, I'm not trying to be coy or insult your intelligence by avoiding obvious terms like average. But as we'll see in upcoming videos, central tendency is more than just the average. And it can reflect things that are not the average. Central tendency, again, gets at the idea of what's the typical middle-ish sort of score. In this case, there does seem to be a fairly clear middle point of central tendency, right around 3,000 to 3,499 grams. Then there's the feature of how spread out the scores are, their variability. In statistics and research, we spend a lot of time thinking about and studying variability. Why are some babies born very low birth weight, while other babies are born 5,000 grams or more? I mean, that's 11 pounds. Oof. What outcomes do we see for babies in both of those groups? The world is full of variability, and understanding that variability is key to understanding the world. Why do some kids read very well and other kids don't? Why do some children facing challenges excel and others struggle? Why are some people generally positive and happy and others fight against depression? But I digress. But only a little bit. As you can see, variability is a key feature for any data. Is everybody close together near the middle, or are they all spread out across a large range of scores? Again, we're going to spend a lot of time using variability in different ways to help us understand everything. Now, the third key feature that I want to talk about in this video is the overall shape of the distribution. In particular, is it symmetric and kind of a mirror image of each other on both sides of the middle? or is a little lopsided or stretched one way or the other way. This is a distribution, well, this distribution for birth weight is pretty symmetric, right? But not perfectly so. Okay, now let's look at some other real-world examples that illustrate ways in which the frequency distributions vary based on the ideas of central tendency, variability, and shape or symmetry. First, there's what's called a positive skew. We see it here in this distribution of math proficiency levels for students identified as being eligible for free or reduced lunch. Notice that the distribution is not symmetric. One half is not a mirror image of the other half, right? It's distorted and stretched out into a positive direction, right? It's, well, in extremely positively skewed data, you may have a lot of scores clustered close together at the low end of the range, but then a relatively few scores stretched way out into the high positive end of the range. Now, income is an example of something that can be very positively skewed. Most households have incomes below $100,000, but around 10% have incomes over $200,000, and 1% have incomes above $500,000. As we'll see later, when data are not symmetric, when they're skewed, those extreme scores can influence how you examine and how you interpret what you see. Now, here's the flip of that, negative skew. This is the distribution of math proficiency levels for all students. Notice it's the same outcome, but the direction of the skew changes based on the students you're looking at. In this case, the data are pulled or stretched in the negative direction. Things may change from group to group, and as we'll see, particularly in more advanced statistics, that can influence how you look at and interpret the results. Now, this is educational data, but outside of education, researchers, policymakers, and businessmen, it can be very interested in things like how skewed distributions are. For example, Amazon spends a lot of money trying to understand what's behind the shape of different distributions in customer ratings. Let's take a look at a few of these. Here are Amazon ratings the time I made this video for the classic sci-fi movie Soylent Green.
You gotta tell him. You gotta tell him.
Promise, Tiger. I promise. I'll tell the exchange.
You tell everybody. Listen to me, Hatcher. You gotta tell him. Soylent Green is...
No spoilers. It really is a classic. If you're into sci-fi, in my opinion, it's definitely worth seeing. Again, as kind of a classic example of a sci-fi movie. Now, notice how this reflects an even more pronounced negative skew, right? Most people really, really liked it. Only a few gave it very low ratings. But sometimes it can get a little more complicated than this. For example, here are ratings for the Hobbit trilogy. Notice it's not just negatively skewed. There's a little of a bump down here at the lowest ratings. Now, of course, a lot of people really liked it. Then the ratings tapered off before there was again a more modest increase again at the very lowest levels. You may see this referred to as a J distribution. I mean, notice it does kind of look like a J. Now, it's not such a smooth trend anymore, is it? Again, yeah, most people are on one end of the scale. In this case, most liked it. But there's a clear group of people down here that definitely did not. And Amazon, and I suspect movie studios, again, spend a lot of money trying to understand who those people are. I mean, I got to admit, I'm in that crowd. I mean, come on. 3 movies based on a book that's like that thick. I mean, a lot of material in the movie had nothing at all to do with the book, but again, I digress. Our next example takes this pattern even further. Here are ratings for The Last Jedi. We'll see shortly what we mean by mode, but in essence, a bimodal distribution has 2 distinct peaks, and that's what we see here, right? People loved it and rated it a 5, and almost the exact same number of people hated it and rated it a 1, with relatively few people in between. You see this type of distribution and you start to think that maybe it's not so much of a wide range of varying opinions. Instead, maybe it's really just 2 groups. You love it or you hate it. Now, by this point, you might be thinking, what's the big deal? I mean, these are just minor, picky little distinctions that really only a real over-the-top, fussy sort of person would care about.
What color is the new carpet?
Going up a shade to harvest wheat.
I thought the next shade up was buff.
It used to be, but they've discovered a whole new color in between.
So now it's tofu, putty, oatmeal,
Almond, harvest wheat, and buff.
That's going to be hard to get used to.
But this isn't trivial. Think about the implications here. In research and in life, we're often talking about the typical person or the average person. What's the average person's view on this? Or what's the average person's view on that? But what does that even mean in a case like this? I mean, the average rating for The Last Jedi is approximately 3, and we can talk about the average rating of 3, and we can talk about the person who gives it an average rating of 3, but almost no one did. If I'm Amazon selling videos or Ryan Johnson, the director, making movies, do I care about what the average person thinks when there's no one who's average? I mean, come on. No, I'm interested in why do those people love it and why do those people hate it. At least that's how I would look at this if I were in their shoes. Now, in upcoming videos, we'll dig into central tendency and variability in more detail and see how those ideas and the shape of the distribution set the groundwork for so much of what we do in research and statistics. With that, let's wrap up this video, okay? Take care. Bye-bye.